Hey everyone, welcome. In this video, we are going to learn about the basics of HatchXR Workspace. We are going to learn how you can design your very own 3D games on HatchXR and learn about the basics of coding, how you can write simple code in HatchXR using JavaScript and make your game do stuff. Alright, so let's get started. First of all, open up the HatchXR Workspace. You have to go to hatchxr.com, and once you open up hatchxr.com, you will be greeted with this website. Alright. Now, HatchXR has two different types of workspace. One is the blocks-based workspace and one is the JavaScript workspace. This lecture series is going to be focusing on learning about the basics of JavaScript. So we are going to open up our JavaScript workspace. And you can open up the JavaScript workspace by clicking on this code with JavaScript button here or this new project button here. Alright. So when you click on the new project button, it will open up this scene here. So as you can see, the HatchXR workspace has opened up on my desktop. So let me just full screen my window. And now you can see that this is my workspace. So this is where we can design our 3D games and code our 3D games using JavaScript. So let's understand what exactly are we looking at. So on the top, you will see that there are three buttons here. It says design, code, and play. And currently design is highlighted. What this means is you are in the design area of the HatchXR workspace. Okay, so you are in the design tab, and the design tab, the functionality of this design tab is that you can design your 3D game here. Okay, so all the objects, you can add different types of 3D objects and you can design however you want your game to look like in this tab. And then there is a code tab. So when you go to the code tab, you will see that this is the place where you can write your JavaScript code and add lots of different functionalities to your game. And then at the very last, there is a play tab here. This is where you can play your game once you have written your game and once you have designed your game completely. All right. So let's first understand our design workspace, the design tab, and then we will explore about the code tab. Okay. So in the design tab, now the design tab is divided into four different sections. It has this left panel here that has a list of some names. And then there is this big central area here. This is called the game inspector. Okay. This is where you can see how your game is going to look like for everyone. All right. And then along with that, you will notice that when you click on any of these objects that you have added in your game, a right side panel appears that displays the properties of your objects. Okay. So the right side panel contains the properties, the left side panel contains a list of names, and the central area here shows you how your game is going to look like. So these are the three main sections. Along with that, you will notice that there is a toolbar on the top here that contains these different icons. These icons help you add different types of 3D objects in your game. The 3D objects, so you can add a lot of different types of 3D objects. So what we have done is, all of these 3D objects that you can add to your game are divided into different categories. So you will notice as you hover your mouse over each of these icons, you will see the type of objects that you can add to your game. So the very first category here says basic objects. So if you click on this basic objects, you will see that this will let you add simple 3D shapes like cube, cone, cylinder, sphere, and just basic 3D shapes. All right. And then you have the second category here that says 3D models. When you click on this 3D models, you will see that this category lets you add complex 3D shapes into your game. So you see there are some 3D objects visible here, and there is a search bar. So you can search for whatever object you want to add. And if I search for, let's say, rocket, you will see that it will give me suggestions for different types of rocket 3D models available that you can add to your game. All right. And similarly, there are also different other types of 3D objects that you can add. There are animated 3D objects you can add using the Sketchfab tab here. Then you can add player avatars. We will go into the in-depth details of each of these categories as this series progresses forward. Okay. So the second category here lets you add complex 3D models. Now then we have a third category here This is called environments. So this tab here lets you create or design your own game environments. So you can see it provides you with different options of adding your ground or a Minecraft terrain, a maze to your game, some sky, stars, rain, snow, particle system like fire, dust, then clouds, oceans, grass, and buildings. So you can use a combination of these objects to create your very own 3D environments for your game. All right. Now, if you don't want to create your own 3D environments, then we also provide you with some built-in templates. So this built-in templates provides you with pre-prepared environments that you can directly add to your game. All right. So this is the third category. Now, there is a fourth category here that is called text. Text simply lets you add 2D or 3D text to your game of different fonts. So you can see the fonts are labeled here, and you can select whether you want to add 2D text or 3D text in your game. And along with that, you have some light options. Light are the objects that help you see everything else in the game. If there were no lights, then just like the real world, you will not be able to see anything in the game. Okay. And then you have some more categories like the option for adding images, sounds, and videos to your game, the options of adding portals and hotspots in your game, and some UI elements to make your game playable on different devices, like on your phone, on your laptops, on your desktops, on your VR headsets, in different devices. Okay. So, yeah, we'll be using each of these categories when we design our own games. All right. So that's the top toolbar. And you'll notice that this inspector area here. So as you keep on adding more and more objects, what will happen is this game area will get populated by all of those objects. Now, for our computer to identify each of these objects, what it does is it gives each of those objects a unique name. All right. Every object has a unique name. And those are the names that you see in the list on the left-hand side panel. Now what happens is you can select an object by clicking on the name of the object on the left panel. Or you can select an object by clicking on the object directly in the inspector. So whenever you select an object, you can see which object is selected by the left panel here. You can see the name highlighted here. And in the inspector area, you can see the object highlighted with this blue boundary. And then whichever object is selected, you can see their properties here. All right. So let's understand some of the basic properties of any object. So you will notice that as you select this, so we have in this game, you see, we have a box, we have a cylinder, and we have a sphere. Now, as you click on each of these objects, you will see that the properties panel changes. It shows properties unique to each of these objects. So every object that you add may have some unique properties of their own that will be available on the right panel here for you to modify the way your object is going to look in the game. But you will also notice that for all the objects, there's this basic properties that stays constant for all of them. So every object here, if you click on different objects on the left panel, you can see they have these basic properties that stay the same. So I just want to explain what these basic properties are, because this is going to be important for you to understand how you can design your own 3D games in Hatch. Okay, and even how you can code your games in Hatch. So let's look at the basic properties. You will see the basic properties contains 3 sets of properties. It says position, rotation, and scale. All right. And position, rotation, and scale. And all of these position, rotation, and scale properties have 3 values. They have an X value, they have a Y value, and they have a Z value. So what happens is we are building a 3D game, right? We are building a 3D game. Now, why are we calling it a 3D game? Because it's a full 3-dimensional space, and it's different from a 2-dimensional space. In a 2-dimensional space, you can move an object only left or right and top and up and down. All right. But in a 3-dimensional space, you can move your object left, right. You can move your object up, down, and you can move your object front and back. So you can move your object in 3 sets of direction. You can move your object left, right, up, down, and front and back. So for those of you who are wondering how am I navigating in this inspector area, there are lots of ways you can navigate. First of all, you can use the arrow keys on your keyboard to move front, back, left, and right. Okay, so you can move front, back, left, and right using the arrow keys. But as I said, this is a 3D game, so we should be able to move up and down as well. And for moving up and down, we have these arrow buttons on the screen here. So you see, we have the generic 4 arrow keys that will help you move up, down, left, right, front, back, and left and right. And then you have the 2 arrow buttons here that will help you move up and down. So just like you can move in 3 sets of directions, your objects can also move in 3 sets of directions. That is why this is different from a normal 2D game that you may have coded in your earlier lessons on different platforms. So now you see the benefit of building it in 3D game is now when you have these objects, because you can move these objects in 3 sets of directions. So that is why you have these position, rotation, and scale values having 3 sets of numbers. One defining their x direction properties, and the another one defining their y direction properties, and the last one defining their z direction properties. Now, what do these x, y, and z stand for? So first of all, let me open up a whiteboard, and here, let me draw 2 lines. Now, on a sheet of paper, what we can do is we can move our pencil either left or right or up and down. Okay, and any way we move our pencil can be broken down into a combination of moving our pencil left and right and up and down. Okay, and that is how our in mathematics and in computers machine is able to identify the direction of motion and how an object is moving. Okay, what it means is the reason. So what I'm going to show you is why we need these directions. Okay, because see, let's take an example of a person standing on a globe. Okay, on this is, let's say this is Earth, and we have a person standing on the North Pole. Okay, this is the North Pole, the top of the Earth. And then there is another person standing on the South Pole. Okay, so he will be standing like this, right? Now, see, for this person, if you were to ask what is his up direction, that he will say that this is the up direction for him, right? But for this person, if you ask what is his up direction, he will say that this is the up direction. Notice that the up direction for both of these people, for both of these persons, are different directions. So what happens is this up, down, left, right, front, and back. These are all relative and they vary from person to person. Okay. Now, when these set of directions vary from person to person, if you tell your computer you want to move an object in its left direction, that left direction or right direction can vary from computer to computer as well, from where you are looking at the object, right? So, because these are relative sets of directions that may change, so we cannot use these directions to tell our computer to move an object. Okay, what we need to do is we need to define a set of directions that stay constant irrespective of where the person is standing or where the person is looking at the game. So because of that, what we do is instead of defining direction in terms of left and right and up and down and front and back, what we do in mathematics and in science, in all the fields of science, in computers and everywhere, is we define these set of directions using number lines. okay, using number lines. Now, number lines are some of the basic concepts that you learn in mathematics in your first and second grade itself. And let me show you here. What happens is, let's say this is a number line, and this number line has a name. It's called the X number line. Okay. Now, let's say this is the center of this number line, and this is the number 0. Okay. So the numbers on the right side of this number line will be 1, 2, 3, 4, 5, 6, and so on. Yeah. Now, what will happen is, let's say we have an object placed on the number 4. Okay. And as we have the object placed here, now see, whether a person is standing here, upside down, or a person is standing here, straight up, if we ask both of them, yeah, where is this object? So this object for this person is on his right side, but for this person, the object is on his left side. Okay. But if you were to ask to both of these people, where is this object on the X number line, they will easily say that the object is located at the X number of 4. Yeah. So irrespective of where the person is standing at, using this number line, they can easily identify where an object is located at. Okay. So this is the benefit of using number lines to define the position and motion of objects in science, in mathematics, and in computers. Okay. So now you see, when we just define an object's position on one number line, we can make it move, let's say, left or right. Yeah. So we can make it move left. We can make it move left or right. And the left or right motion can be defined by identifying whether the X position, whether the position of this object on this number line is increasing or decreasing. Right? As the object moves to a new position, the number, the X position number of this object will change. So if we want to make this object move in this direction, let's say this is the positive X direction and this is the negative direction. Okay. So if we want to move this object in this direction, we can just increase the X position number. Okay. And if we want the object to move in this direction, we can just decrease the X position number of this object, and that will make this object move towards the left or right direction. All right. Now, similarly, if we were to add another number line on top of this X number line, okay. So we have the X number line that's defining the left or right direction. Similarly, if we were to add another number line like this, okay, and call this the Y number line. Now, if you're, let's say, we have a point here, okay, I'm going to call this point P. Let's say there is a person standing on this point P. Now we can say that for our purposes, what we say is the point where this X and Y number lines meet, it has the X position of 0 and the Y position of 0. Okay. Now, as this point moves to the left and right, this point is going to have what? It's going to have an X position. Okay, that is going to be this value. Okay, you can call this number A on the X number line. And then this point, see, we are using the X number line to define the point's position in the left and right direction. Okay, and then similarly, we can use this Y number line to define the point's position in the up and down direction. Okay, so now what happens is this point P will have an X number line value. Okay, and then this point P will have a Y number line value. So you see that every point on this X number line, and if you mark out all of the points on the Y number line, then any point on this sheet of paper can be defined by a combination of the X number line and Y number line, right? Choose any point on X and choose any point on Y, and if you draw straight lines from there, you will get a unique point. So what I'm saying is every point on the sheet of paper has a unique number on X and Y. So let's say there is a point here that is 2 units, that is on the X number line 2, okay, and that is on the Y number line 1. That means the position of this point, let's say this point is called M, okay. So point M has the X position of 2 and Y position of 1. Now what I'm saying is there is only one point M such that point's X position is 2 and Y position is 1. There can be no other point on this entire sheet of paper where the X position is 2 and Y position is 1 when you draw these X and Y number lines. Okay, so every point will have a unique X and Y, unique combination of X and Y number values. And the benefit of this is now, let's say this point P, I want to move this point P in some direction like this. Okay, now what we can do is, see, when we want to move this point like this, what we can do is we can break down this path into a collection of multiple points, right? We can break down this path into a collection of multiple points. And what happens when we do that is, if we can tell our computers, or even in mathematics, if we can define the equation of this path used by knowing the X and Y position of each of these points, then we will be able to uniquely move our point on this path. If your computer knows what each of these points' values are in X and Y, then your computer will be able to move the object uniquely on this path, right? So that is how we move an object in a 2D space. So right now this is a 2D space. It only contains two sets of directions, X and Y. There is no third direction here. Now what we are doing in Hatch is we are making a game in 3D. So all we are saying is, just like in a 2D space we have the X and Y positions, we are adding another set of direction called the front and back direction, and that is defined using the Z number line. So now let's say I have a point here in a 3D space such that this point has an X, Y and Z value. See, imagine this point in a 3D space, and if you were to draw straight lines from this point on the X, Y and Z numbered lines, you would be able to identify, see, this distance of this point, right? This distance is the X position of this point. Okay, if I call this point Q in this 3D space, then this is the distance of this point on the X number line. This is the X position. And then this is the Y position. Okay, this is the Y position, this is the X position, and this is the Z position, the front and back. Okay, so a unique combination of X, Y and Z will give you a unique point in the 3D space. And using that you can identify where an object is located at. Okay, so when you go back to the Hatch Workspace, you will see that for every object here, for every object, you see there is a center point that marks the identifying position. So you see every object has a center, and this center, the position of this center point in this 3D space in terms of its X, Y and Z number, X, Y and Z position, is defining where this object is located at. And you can see, like for this box, the center's X position is 1, y position is 0.5 and z position is -3. Even the x position is -1. Okay, and if you look at this player object here, you will see that the player object, which is situated here, okay, at this point, this player object has the position of x number line 0, y number line 0, and z number line 0. So the position of all of these other objects are defined with respect to that 0, 0, and 0 point. It means that when you say that the box has the x position of -1, it means from the x number line, the box is 1 units in the left direction. It's -1 units on the x axis, on the x number line. Okay, and then when you say that the y position of this box is 0.5, it means that it's 0.5 units up on the y axis, on the y number line. And then when you say z is -3, it means that the box is -3, is 3 units behind the 0 point. Okay, so this is how we are able to identify where an object is located at, and we would be able to tell our computer where to move an object when you want to add motion to an object. Cool. So just like we have position, we also have rotation and scale values for every object. Now scale has x, y, and z values again, and scale controls the size of an object. So because this is a 3D world and all the objects are 3D, it means the objects have three sets of dimensions, right? The objects have height, the objects have a width, and the objects have a depth. So you can change the height, width, and depth of an object by changing the scale in x, y, and z. So you see, I have this box here. I can make the box wide. Okay, so the box is rotated right now by 45 degrees. As you can see, the y rotation is 45 degrees. Let me change the rotation back to 0 here, and let me show you then. So as you increase the x scale, you are increasing the width of the box, right? And as you increase the y scale, you are increasing the height of the box. And then as you increase the z scale, you are increasing the depth of the box. So you can change the size of any object by manipulating the scale numbers. Okay, x, y, and z numbers. And then similarly, we have x, y, z rotations. So what you can do is, see, the way I'm changing these numbers are when you move your mouse over any of these numbers, you will notice that your mouse changes into double arrowheads. Now, whenever your mouse changes to these double arrowheads, you can click on the left button of your mouse and then drag your mouse left and right to increase or decrease the numbers. Okay, and you can see how changing these numbers affect the presentation of your object in your game. Okay, so here let me show you. If I change the x position, you can see that as I move my mouse to the right side, the x number is increasing and the box is moving on the positive x number line. Okay, as I move my mouse to the left, I can see the x number value is decreasing. Okay, and the box is moving on the negative x-axis. Similarly, I can increase or decrease the y position. I can increase or decrease the z position. So this is one way of changing the numbers. You can directly type in the numbers here as well. You can just click on these boxes and type. If you know where you want an object to be placed at, you can just type those numbers by clicking on these boxes. Or if you want, you can, so you will notice that whenever you click on an object, every selected object is provided with 3 arrowheads, red, green, and blue arrowheads that are indicating the x, y, and z directions. And you will notice that as you move your mouse over these arrowheads, you can basically move your object in those directions by pressing on the left button of your mouse. So whenever you move your mouse over these arrowheads, they turn yellow. When they have turned yellow, if you hold down the left button of your mouse and move your mouse, you will be able to move the object in that direction, in that selected direction. Okay, so that is another way you can move an object. Now, similarly, as we were saying, we have scale and we have rotation. So rotation is also having X, Y, and Z directions. So see, when I change the X rotation, you see the object is rotating around the X axis, around the X number line. See, this is the X number line and my box is rotating around the X number line as I'm changing the X rotation. And let me set it back to 0. Now, if I change the Y rotation, see, the object is rotating about the Y axis. Okay, about this Y number line. And then, as you change the Z rotation, you will have your object rotate about the Z number line. So, you have X, Y, Z rotations, you have X, Y, Z positions, and you have X, Y, and Z scale. And by changing these values, you can decide how your object is going to be presented in your game. Where your object will be positioned at, what will be the size of your object, and what will be the orientation of the object. Along with that, there are other properties as well. So these below, the properties listed below are going to be unique for different objects, and we will explore those properties again in our future lessons. Okay, this is just a walkthrough of how to identify, how to modify an object's presentation in your game. All right, so yeah, now that we have covered X, Y, Z position, rotation, and scale, what we can do is let's also look at the visible property here. So this visible property is having a check mark. This means that the object in your game is currently visible. If you want to have an object that is sometimes visible in your game and sometimes not visible in your game, you can use this check mark to make the object visible or invisible. We can do it through code as well. I will show you. You will be learning how to turn on and turn off the visibility of an object through code, but just showing you in the design tab also, you can add an object but make them invisible by removing the visible check mark from here. So these were the basic properties. Now, let's also learn how to delete objects, how to rename objects. So in case what happens is whenever you add lots of 3D objects, some names of the objects might not be what you want. So on the left panel here, you will see that whenever you select an object, that selected object is provided with a 3 dots menu on the left side. Okay, so if you click on these 3 dots, it will give you with a menu option that provides you with the option to rename the selected object, to duplicate the selected object, or to delete the selected object. So if you click on the rename option, then you can type a new name. Whatever name you want to give your cylinder, give your selected object and then press enter, and your object will have a new name now. So this is how you can rename objects. To delete an object, you can just select your object and press the delete button on your keyboard. And you will see that now I deleted the cylinder object. If you want to undo an action, there is this undo button on the. So if you click on the undo button, you will see that the delete action has been undone. So now I have the cylinder back in my game. If you want to redo an action, then you can click on this redo and the cylinder gets deleted again. So you have undo and redo, and then there is this zoom option. So sometimes you may be either far out in the scene or you may not know where you are. So what you can do is you can use this zoom option. You can use the plus and minus zoom buttons to zoom in and out of your scene. And if you do not know where you are looking at, if you do not know where you are in the game, then what you can do is, let me just show you. Sometimes we may get lost at where we are in the scene. Like this, right now everything is so blue and I cannot figure out where I'm looking at. So what can happen is sometimes you may get lost like this, and in that scenario, do not panic. You can just click on this reset camera to center button, okay, on the top here. When you click on this, it will take your camera back to the original position where it was. Okay, and now you can move around. Cool. So we learned how to navigate in the design tab. We learned about the basic properties of position, rotation, and scale. And we learned how to rename objects, duplicate objects, delete objects, and then how to add different types of objects and the basic layout of the design tab. Let's just go to the code tab and understand the basics of the coding window. Okay. So now you can see when I go to the code tab, I have the same left panel here, but it has a bit more names on the left side here. And then there is this huge code editor that says write your code below this line. So this is where you can write whatever code you want to write. Okay. And then you have the game on your right side. But you will notice that right now there is no code running in this game. So whatever code you write in your project, if you want to run that code, okay, you can write your code here on this left side. And whenever you want to run this code in your project, you have to click on the run script button. Okay. Now, when you click on the run script button, whatever code you're writing here will run. And if you want to stop the code from running, you can click on the reset button. Now, once you have your game ready and completed, then you can also publish your project by clicking on the publish button. So anytime you click on the publish button, it will give you the option to give your project a name and give your project a description. Once you give your project a name and a description, you can publish your project and it will generate a unique link for your project and you will be seeing a QR code of your project. Okay. So the QR code of your project is going to be useful whenever you want to run your project in your mobile phones. You can scan the QR code using a generic mobile QR code scanner, or you can scan your QR code using the Google Lens on your phones and run your game on your mobile phone browsers. All right. Otherwise, you can just copy paste the links of your project and share that with whoever you want to share. Cool. So this was the basic of how to use the Hatch Workspace, how to just to understand where everything is located at, so that when you start coding, when you start building your own projects, it's easier for you to navigate around in the Hatch Workspace. All right. So from our next lesson onwards, we will start building our own games. All right. So see you guys. Bye bye.